right, we're back with page 2 of the volume of prisms. Remember that we said a prism is any shape that I can turn into a layers of slices, okay? So the front of this shape could be shaved off and give me another copy of it behind it over and over and over until we got to the back of the shape, and they would all be the same slices. And we also said that the volume of one of these shapes is equal to the area of one slice, which we'll just use the base because it's, the bases are the front and the back. So if we find the area of one base, and I don't mean this up front, I mean the trapezoidal shape that we're using for a base. Okay, that is the slice that we're talking about. If I find the area of that one slice and then multiply that by h, however tall we're stacking those slices. And in this case, we're going to stack those slices 4 meters tall, okay, because the slices are kind of going on end here. So I'm going to stack them back to front 4 meters wide. So what I need to do is now find the area of this front shape, and I think we've recognized that to be a trapezoid. If you have trouble trying to figure out how to do a trapezoid, you can look at it as a rectangle with a couple triangles. That makes it a little more difficult, but we do know that the whole length here is 8 and this length's 3. That leaves 5 for the rest of this triangle together. But I'm just going to go back to that trapezoid formula. In the trapezoid formula, we said you're going to average the length of the two sides, because what we found out about a trapezoid is this. However you cut it, if I do this, I can turn this into a rectangle, that has a width equal to this midline here called the midsegment. And that midsegment is going to be the average of the top and the bottom. So if this is 8 and 3, then this midsegment is going to be the average, which is 5.5, right? 8 plus 3 divided by 2. So that's going to be 11 divided by 2. Okay, so that comes back to this formula. The area of a trapezoid is going to be base 1 plus base 2 divided by 2 times the height of that trapezoid. So h of the trapezoid. Okay, we got to be careful. Height of the shape, height of the trapezoid. Man, we got all these different things we're talking about. So that's going to be 8 plus 3 divided by 2 times, this is the height of that trapezoid we're talking about. That's 4.3 meters. Okay, that's 8 meters plus 3 meters divided by 2 times 4.3 meters. Meters times meters is going to end up being meters squared. And so I'm going to have 5.5 times 4.3. All right, so let's see if I can do this in my head. 5.5, that's like 55, okay, times 4. So that's going to be 220. Move that back, that'll be 22. So 4 times 5.5 is 22. And then 0.3 times 5.5. Well, let's just do 3 times 55. 3 times 55 is going to be 150 plus 3 times 5 is 15, so 165. But I got to move that back 2 decimal places. This is going to be 1.65. So I'm going to do 22 plus 1.65 is 23.65. And just in case, because Mr. Conaway does a lot of crazy math in his head, let's just make sure. 5.5 times 4.3. 23.65. Sounds good. Okay. So 23.65 meters squared is going to be the area of that trapezoid. But the volume formula tells us that we need to stack that h units tall. But this h is a different h than the previous h. That h was the h of the triangle. This h is the height that we're going to stack it, meaning from front to back, how thick is this shape. So that's going to be the area of the base, the trapezoid, was 23.65 meters squared, and the height of this shape is 4 meters. So when I multiply those together, well, 4 times 20 is 80, 4 times 3 is 12, so that's 92. 4 times 0.6 is 2.4, so it's 94.4. And 4 times 0.05 is 0.2. So I think that's 94.6. But let me check once again in my trusty calculator. I might have got something wrong there. 23.65 times 4. 94.6. Looks like we're good. Okay. And that is the final volume of that shape. These are much easier. Once again, there's really no set formula for this. You could do something like base 1 plus base 2 divided by 2 times HT times big H. But it's easier just to say area of the base times the height. All right, we did one of these just like this one on the front page, so I'm going to skip number 3 and let you guys work, or sorry, number 8 and let you work that. We also did a cylinder on the front page. This one gives you the diameter versus the radius, but I'm sure you guys can work that one without me. So let's look at number 10. So we've got a triangular base. Now, how do I know that's the base? Well, it's the only way I can slice it and get the same size slices over and over. You see, if I slice it right here, I'm going to get the same shape as the top and the same shape as the bottom. So that's the way I know which one's the base. That's the slice I'm looking at. So the volume is equal to the area of that one slice, which is the same as the area of the base. Okay, the top or bottom is the base, times the height with which we stack it. Now we're going to stack this thing 10 kilometers high. Good Lord, these guys are trying to stack it into space here. So let's take a look at this and say, well, how much is the area of this one triangle here? Well, if I look at the bottom one, I apologize about that, guys. The bottom one has a base of 9 kilometers and a height of 6 kilometers. Okay, so that means if I do the area of that triangle, then I've got base times height divided by 2, where the base is 9 kilometers, the height is 6 kilometers, and that's divided by 2. Multiplying those together, I'm going to get, let's see, that 6 divided by 2 is 3, so 9 times 3 is 27 kilometers squared. So the volume formula, once again, is going to be that area of that triangular base, times the height. So that's going to be 27 kilometers squared times that height that we're stacking it of 10 kilometers. So that's going to be 270 kilometers cubed. 270 kilometers cubed. Okay, great. Let's look at some of these word problems. So these are pretty simple. 11, a cylinder with a radius of 4 yards and a height of 5. I don't really think that we need to work on that one. You guys should be able to draw a cylinder with a radius of 4 and a height of 5 and be able to figure that one out because we've got a formula for those. How about the square prism measuring 6 kilometers along each edge of the base and 5 kilometers tall? So this is a square prism, which we talked about a little bit in class the other day, meaning the top of it is a square. What does a square mean? Well, it means that all 4 sides are the same, okay? And then however long this rest of these sides are, they don't necessarily have to be the same as the top. So this is 6 kilometers, once again, very huge, 6 kilometers, and this is 5 kilometers tall here. Okay, and so we can go back to that volume formula that we said was area of the base times the height. So that's 6 times 6 times the height. Or we could say it's length times width times height. I kind of like that formula. So that's 6 kilometers times 6 kilometers times 5 kilometers. And that's going to be 30 times 6 is that 180 kilometers cubed. Okay. So we've got two more here. This is a hexagonal prism, 5 yards tall, with a regular base measuring 5 yards on each edge. And then this is a trapezoidal prism. So for number 13, you should refer back to the picture on number 2. That's very similar to what we're talking about here. And for number 14, you should refer back to the picture on number 7. Those will be very similar. Okay, and I will see you on the next page for pyramids and cones.